Hey guys, welcome back for another Trick Tip Tuesday. And for today's tip, I'm going to talk to you guys about my preferred method for cutting stainless exhaust material. So um, I've seen a lot of guys try to do a lot of different things with cutting, using chop saws, all that kind of stuff. Obviously, no matter what, you got to use what you have as far as cutting that. But as far as like if you're looking for the best type of machine, the best process for cutting stainless exhaust, and really this could ultimately be used even on steel exhaust material, that sort of thing. But stainless especially, because stainless is hard. So everything I use when it comes to exhaust, header tube, that sort of thing, it's all 304 stainless. So it's a nice grade of stainless, and it can be definitely hard to cut. So if you're just dealing with long straight lengths and you're just trying to get it cut shorter, a good horizontal bandsaw works well for that. Got to make sure you use the right tooth count. So obviously, because this stuff is thin wall, I like to use a pretty fine tooth blade, somewhere in the kind of 14 to 18 teeth per inch range. I found that I actually prefer a straight, just a straight tooth count. So there's a lot of blades for bandsaws have kind of a variable tooth count. So in you'll find like a 10 to 14 teeth per inch, and it kind of, if you look at it, you'll see the teeth get bigger and smaller as it goes through. I've actually found that I prefer a straight tooth blade as far as the tooth count. So if it's 18 teeth per inch or 14 teeth per inch, and that's it. And that's just based on experience cutting it. I myself wouldn't even know the exact technical reason why. I've just found that I prefer that. So, when it comes to cutting a bend, when this material is mandrel bent, obviously it's stretching the outer edge of the tube, through the bend. So when you go to cut that, there's a lot of stress in the material. And that's why when the bend is made and you look at it, it looks really nice, it looks round, everything looks good that way. But as soon as you cut it, if you look at the shape this way, the shape is going to be, slightly oblong, or it's going to be kind of D-shaped, where it's going to be nice and round on one side and a little bit flatter on the other. There's going to be some different profiles in there, especially depending on how tight of radius of bend you are dealing with. So, what all that stress in the tube on the outside edge can cause is, as you're cutting through on a bandsaw, it can actually, because you bent this tube this way, it's actually trying, the material itself is trying to unbend itself just a little bit all the time. But that's just, it's bent, it's staying there, but as soon as you start to cut it, you're starting to create a relief in there, so it's trying to unbend as you're doing that, because the material is just fighting itself naturally based on what you just did by bending it, or by buying that bend, running it through a mandrel bender. It just has that stress in it. So as you're cutting, it's actually trying to pull the material into the blade. So as the blade starts to travel into the tube this way, the tube itself, based on the gap that you're creating, is actually trying to pinch closed. So as it's doing that, obviously it starts to drag on there. And I've used bandsaws that are not intended for cutting metal before, because that's what was available. And you might find that it actually it's pinching hard enough to where, wood is a lot easier to cut through on a bandsaw than metal is. So if your bandsaw is not, let's say it doesn't have enough power to cut through the material, I've actually had it pinch, and then actually pinch the blade so hard that it actually slowed down or stopped the bandsaw. Now, obviously on a saw like this, you're not going to have that issue because it is made for cutting metal. But even with that, it can still have that tension on it to kind of pinch onto the blade. So you need to make sure that you're cutting on on a proper bandsaw for cutting metal, number one. And I don't like to cut on bandsaws that have too narrow of a blade in this way. You know, so this right here is a 1-inch wide blade, and that is about the narrowest I like to go. 3/4 wide you can get away with, but I find that the wider the blade, the straighter the cut on the material. And naturally, obviously, because the blade can deflect less as you're cutting through there. So the wider that blade is, the straighter the cut's going to be on your tube. So it's not as noticeable on a smaller diameter tube like this, but once you start getting into like a 2.5, 3-inch, or in that range as far as the diameter of your tube, the narrower the blade, the more the blade wants to kind of deflect, and you'll kind of end up getting a little bit of a kind of a C shape a little bit in your cut, to where, and part of that, so there's 2 reasons for that. There's blade deflection, the stress in the tube, and then so as it's doing that and you're cutting, you're not allowing the blade to travel totally straight, because say as you're trying to put your pressure into the saw, the blade starts to deflect, and then as you're trying to follow your line, you end up moving the tube a little bit and that sort of thing to follow your line. So yeah, the wider the blade, the better, especially on bigger material. It's not as noticeable on, like I said, on narrower diameter tubing, but I've actually used up to like 1.25 inch wide blade, and man, you get a really nice straight cut across your tube, especially when you're trying to build headers, you know, put stuff together. It's the straighter you cut here, the less time you have to spend on a grinder to be able to grind that surface flat to join it up, you know, with a new tube, you know, that way. So yeah, so I guess some of my tips overall would be, make sure you're cutting with the right blade. I prefer a bandsaw. I have used a number of different types of saws, or attempted to use a number of different types of saws, from the kind of bench top chop saws to bench top bandsaws, as far as like a chop saw style bandsaw. They can do it. It's just not the cleanest cut, and it just doesn't do as good of a job of creating less work for yourself. So if you're doing a lot of exhaust, a lot of headers, you definitely want to go with more of a dedicated vertical bandsaw for being able to make the straightest cuts on your material, and really helping yourself out in that way. So again, tooth count on the blade, width of the blade, and make sure you're cutting with the right speed on the bandsaw as well. So as you're cutting through, the biggest thing is to let the saw do the work. I've seen in a shop atmosphere where guys take something and they're really just trying to, because the material is so thin, you can just shove it through the saw and get your cut done real quick. Well, this is hard stainless, so the more pressure you're putting on there, the more stress you're putting on the teeth, on your blade, all that sort of thing. So in order to get a better cut, in order to help your consumable, your blade, last longer, you know, let the blade do the work. So when you fire up your saw, just, you know, let it start cutting through, put nice easy pressure on it until it goes through, and you'll get a better product on your cut. So hopefully this tip can help you out in your shop. We'll need to do a cut right here to show you guys kind of how I would operate a cut going through on a saw like this. But if you have any more questions, want any more ideas on cutting your material, give us a call, visit our website at Trick-Tools.com, and we'll be able to help you out. So thanks for watching this week's trick tip. We're gonna get this cut, and we'll see you in the next one.